Welcome back. I hope you're doing well and ready to continue our journey. In the previous chapter, we explored the foundations of master data in production, learning how elements like BOMs, work centers, and routings come together to form the backbone of production processes. Now, we're shifting gears and moving into the exciting world of production planning. This chapter will focus on how we anticipate demand, manage resources, and prepare the system to support efficient production execution. Let's dive in and see how everything connects, starting with the crucial step of defining Planned Independent Requirements, PIGRs. This will set the stage for our Material Requirements Planning, MRP activities. Ready? Let's begin. Before diving into Planned Independent Requirements, PIGRs and MRP, let's take a step back and explore the foundational steps that precede these processes. In real-world scenarios, effective production planning starts well before the creation of PIGRs, with several key stages that ensure the business is aligned strategically and operationally. First, we have Sales and Operations Planning, SNOP. Think of SNOP as the big-picture planning stage. Here, businesses align their sales forecasts with production capabilities, ensuring that the company's overall strategy is realistic and achievable. It's about balancing demand with supply while considering capacity constraints and market trends. Once the high-level plan is in place, we move to forecasting. This involves using historical data, market analysis, and customer trends to predict future demand for products. For example, if your business experiences seasonal fluctuations, like higher sales during holidays, forecasting helps anticipate these spikes and adjust plans accordingly. With demand predictions in hand, the next step is capacity planning. Here, we assess whether our production facilities, workforce, and resources can meet the forecasted demand. If gaps are identified, this stage helps determine if additional capacity, like hiring more staff or investing in new machinery, is needed. For companies using advanced tools, Integrated Business Planning, IBP, may also play a role. IBP takes SNOP to the next level by integrating financial data, supply chain metrics, and other key performance indicators into a unified platform. While IBP is outside the scope of this course, it's important to know that SAP offers powerful tools to streamline this process for larger organizations. Now, let's connect this back to Planned Independent Requirements, PIGRs. PIGRs are a bridge between strategic planning and operational execution. They translate the broader plans and forecasts into actionable, system-defined requirements that guide production and procurement processes. In this chapter, we'll simulate a simplified version of this process. Imagine we've already forecasted demand for a finished product, FP001, and procured the necessary raw materials, RAW001 and RAW002. Using SAP, we'll define PIGRs for FP001 and explore how these requirements feed into the MRP process. By understanding these foundational steps, you'll gain a clearer picture of how businesses transition from strategy to execution, ensuring that production aligns with both market demand and operational capacity. Now, let's see how to execute this in SAP.
In this screen, we return to the main menu and access the Monitor Material Coverage application. We have arrived at the Monitor Material Coverage screen, where we can view all materials under our responsibility as defined by the MRP controller. This screen provides an overview of stock availability, demand, and shortages. The green bars represent stock availability, with varying levels indicating the current quantity relative to planned capacity. This initial overview allows us to assess the situation before making any planning decisions. First, we select material FP001 for further analysis. This is a finished product with no stock, no sales demand, and no planned independent requirements configured. This indicates that there are currently no activities linked to sales or independent planning for this material. This information is crucial as we move forward with our planning process. Next, we analyze material RAW001. This raw material has 100 units in stock, which is the result of purchases made in the previous exercise. The material is available and shows no additional demands or shortages at this time. This confirms that the current stock is sufficient to cover any potential short-term needs. Now we move to RAW002, another raw material. This material also has 100 units in stock, similar to raw 001. The situation is identical. The material is fully available, with no immediate requirements for replenishment or planning. This initial analysis confirms that FP001 has no sales demand or planned independent requirements, while raw 001 and raw 002 are in stable conditions, with enough stock to meet immediate demands. By conducting this detailed assessment, we ensure a clear understanding of the current situation for all materials managed by the MRP controller. This step sets the foundation for introducing an independent requirements plan and proceeding with our planning process. When opening the Maintain PGARS app, the system displays the material FP001, which is associated with the Hamburg plant. This material has a planning interval set to weeks, and the accuracy is currently 100%, reflecting the reliability of its planning data. By accessing the details of FP001, two main sections become available: General Information and Planning Data. In the General Information tab, we can observe key attributes, such as the requirements type, defined as planning with final assembly, the unit of measure specified as pieces, and a reach of 0 weeks, which indicates that no planning data has been applied yet. These details provide an overview of how the materials planning is structured. In the Planning Data tab, the system displays a table with planning details organized by weeks. The table includes fields for planned independent requirements, PGARs, withdrawal quantities, sales quantities, and accuracy, among other values. At this stage, all fields are set to 0, as no planning has been entered. For this demonstration, we will create a planning scenario starting in week 5, while considering the current timeline as week 3. The planning scenario envisions a progressive increase in production requirements. Starting in week 5, the PGARs are set at 10 units. This increases to 20 units in week 6, 30 units in week 7, and 50 units in week 8. For week 9, the PGARs are raised to 100 units. This gradual increase reflects a growing production need over the selected weeks. Before finalizing these updates, it is necessary to revisit the General Information tab and enable the version active setting. Activating this version is a crucial step, as it validates the planning data, ensuring that the system recognizes and incorporates these requirements into the overall material planning process. Without activating the version, the data will not be saved or used in subsequent calculations. Once the version is activated, the planning data in the Planning Data tab can be saved. With this, the process of maintaining PGARs for material FP001 is successfully completed. This exercise emphasizes the importance of validating planning data by activating the version and demonstrates how planned independent requirements directly impact material availability and resource allocation. Properly structuring and confirming the planning process ensures accuracy and reliability in meeting production demands. We've just completed planning the independent requirements. Typically, these requirements are derived from operational sales planning or forecasts, which estimate future demand based on market trends and business goals. For this demonstration, we manually define the independent requirements. Now, based on these planned requirements, we'll proceed to execute the Material Requirements Planning, or MRP. The MRP process is vital for ensuring material availability. It calculates the quantities of raw materials, components, and finished goods required, along with their delivery schedules. By processing the independent requirements, MRP generates proposals for production orders and purchase requisitions, aligning production and procurement with demand. To begin, we access the Schedule MRP Runs application. Once inside, we are presented with an overview of existing jobs. To create a new MRP job, we select the Create option. This opens the job configuration screen. Here, we start by choosing the appropriate job template. The system defaults to Material Requirements Planning, MRP, which fits our needs perfectly. Next, we assign a name to the job that reflects the planning period. For this example, Material Requirements Planning, MRP, Week 03. After verifying the details, we proceed to configure when the job will run. The scheduling options allow us to define the job's start time. For this demonstration, we choose to start the job immediately. While there are options for recurrence patterns, we proceed with a single execution. With the schedule in place, we move to the next step to configure the planning parameters. In this step, we specify the essential parameters for the MRP run. First, we set the plant as 1010, representing the production facility in focus. We then define the MRP controller and material scope as MR1, ensuring the job targets the relevant materials and planning area. To capture detailed outputs, we also enable the job log option. With all parameters in place, we finalize the process by scheduling the job. The system then begins processing the independent requirements, determining material needs, and generating the necessary proposals. This marks the execution of the MRP process. After the job is scheduled, the job log provides detailed information about the execution. It includes key updates, such as the start and end times of the planning process, the materials considered, and the overall scope of the MRP run. By reviewing this log, we ensure that the job was executed successfully and identify any adjustments required. From the job log, we can also proceed to the results section to analyze the outputs generated by the MRP process. After executing the MRP, we return to the system's main screen. From there, we access the Monitor Material Coverage application to review the impacts of the planning on the materials. In the initial Monitor Material Coverage screen, we identify the materials involved in the process. Here we can see the finished product, FP001, and the raw materials RAW001 and RAW002. At this stage, the system shows no shortages, but it indicates planned stock movements to fulfill the demands identified during the planning. We select FP001 to examine the details of the finished product. In the Manage Materials screen, we observe that the MRP has generated planned orders to meet the independent demand previously defined. Each planned order is scheduled for specific time periods, ensuring the finished product will be available as required. Returning to the Monitor Material Coverage, we select the raw material RAW001 to review the dependent requirements. On the Manage Materials screen for this material, we can see that the MRP has generated purchase requisitions due to an anticipated shortage identified by the system. The system, predicting that the stock would be insufficient to meet the dependent requirements for FP001, created these requisitions in advance. This action is critical to prevent disruptions in the production process. We repeat the same review for the raw material RAW002, where we also find purchase requisitions generated by the MRP. These requisitions follow the same logic applied to RAW001, ensuring that the materials are available on time for the production of FP001. With this, we conclude the planning and execution of the MRP. The system demonstrated how, starting from independent planning, it was able to generate dependent requirements, plan the production of the finished product, and anticipate the procurement of necessary raw materials. This seamless integration between planning and execution ensures that the supply chain is aligned with business demands, avoiding failures or bottlenecks in the production process.
Let's take a moment to review Planned Independent Requirements, or PIR, and Material Requirements Planning, known as MRP. PIR represents forecasted demand for a finished product or component. These requirements are usually derived from sales planning or market trends, but can also be defined manually. PIR acts as the starting point for production and procurement planning, providing a baseline demand to guide the process. MRP takes this forecasted demand and calculates the raw materials, components, and finished goods required to meet it. Using the bill of materials and inventory data, MRP determines dependent requirements, which are the material needs driven by the planned demand for finished products. MRP ensures material availability in three key ways. It generates planned orders for producing finished goods, creates purchase requisitions for raw materials when stock is low, and schedules these actions to align with demand timelines. This ensures a balanced flow of materials without overstocking or delays. PIR and MRP work together seamlessly. PIR defines the independent demand for a finished product. MRP processes this demand, calculates dependent requirements for raw materials, and triggers production or procurement activities. The system then generates planned orders and purchase requisitions to keep the supply chain aligned. With this, we conclude the planning and execution of the MRP. In the next phase of production execution, we will explore the creation of production orders based on this planning and their execution. See you then.